Welcome everybody to today's live stream. This is what we're going to be videoing today. It's going to be pretty fun because we are going to be testing this hardtail vise that's right behind me. Before we get started, and as everybody continues to join these live streams on TikTok, Instagram, and YouTube, I'm going to talk for about 5 minutes and kind of give you some updates on what we've done to this machine. But before I do that, I'd like to kind of introduce myself. My name's Jason, and I am the owner of Fireball Tool. And here at Fireball Tool, we build tools and equipments for people who are welders, fabricators, builders. We really like to build stuff for work holding, such as tables, vices, squares, all that type of stuff. Okay, but what we're going to be doing today is we're going to be doing some destructive testing on the hardtail vise. And what I mean by this is something we do on a routine basis to check for quality control, and then what I like to do is continually improve the product. Okay, if you haven't seen this rig behind me before, I have several YouTube videos that talk about it, the build construction, what it's designed for, how it all works. So go check those out if you're kind of lost what we're really doing here. Okay, but what you see behind me is a gigantic hammer. Now, I'm going to kind of walk you through real quickly on how this machine works. What we're trying to do is test components of the vise by hitting it with this giant hammer. We've done some upgrades to it. The original hammer that was on here was 77 pounds. What we're having problems with is that the vise was too strong and we could not get it to failure. We'd have to continue to hit it for hours, if not almost days sometimes, to get it to fatigue and break. So we've upgraded the hammer up to 100 pounds, and we're hopefully going to see some action and some carnage and get this vise to really break. Now, what you see behind me, this is a swinging hammer machine. Well, what I mean by hammer, this really isn't a hammer. This is more like a wrecking ball. That's how it works. This structure, all it's designed to do is lift this hammer up, and then gravity takes over at the top of the stroke and it falls down, striking this test bar as you see right here. Now, the way I have the machine set up right now is when this hammer strikes this test bar, what we're going to see is a loading action between the jaws, which in this little bar is going to try to spread the jaws apart, causing this fusible link, which is called the tube nut, to hopefully break. This is an engineered component to where if vices get damaged or stressed beyond their design intention, that this component breaks first, and this is a replaceable part. So what we're hoping for today is we see this break. That's the goal anyway. We don't want to see threads strip out, we don't want to see bolts or bases break off, we really don't want to see jaws snap off, we don't want to see the head of this snap, we want to see this break, and hopefully we're going to be doing that today. Okay? So for this experiment, I've removed the swivel base. Now this is the swivel base that normally comes with the vise because we don't want to test this in the load. We want to isolate the issues with the jaws and the tube nut. So we've removed it and we bolted it. We bolted the vise directly to this 4,000 pound table or piece of plate steel. And on top of the table, I've welded this piece of 1-inch plate that the vise is bolted down to with 3/4 bolts right through the flange. Okay? So that's how the vise is held down. This vise with the swivel base weighs about 270 pounds, so we probably removed about 20. So we're sitting about 250 pounds of vise sitting here. Okay, so this arm right here is 3 feet long, plus a little bit to the center, so we're about 3 foot 3 inches or so, swinging at a speed of around between 30 and 40 miles per hour, depending on the rig. We're hopefully going to be seeing about 1 stroke every 20 seconds or so. I do have control of the speed, and normally I like to start real slow just to make sure everything's tight, nothing's loose, I didn't miss any bolts or anything, and then we'll gradually turn up the speed and increase the cycle time. At the top of the rig, I have a counter, which is going to count the number of strokes that we are seeing and we keep track for our data. I have 3 strokes already on the machine from previous testing yesterday with setting up, making sure everything's working right, we didn't have any issues, so we're going to be starting at 3 strokes. The other thing, I don't know how long this is going to take. This is just part of our routine. Sometimes we can break a vise quickly, sometimes it's going to take us days. This live stream might be going on for 6 hours or more, I don't know, but we're going to go till failure. Hopefully we don't see the rig break. If it's a minor adjustment, I'm going to jump in here, stop, and we're going to make the necessary repairs to keep the rig going. If the vise starts to loosen up anyway, I'm going to try to keep it going also. But we're just going to let this vise continually get punished by this giant hammer here. Now, this rig gets extremely loud, so loud that you have to have ear protection around it. So you guys can know how loud it really is and be part of the enjoyment of this testing today in the shop. I've included this meter, which is going to show you the volume of what this thing's putting out for noise. And then the time where we're starting, and that way you guys can kind of follow along as you check in throughout the day where we're at and make sure everything's synced up. Okay? So these are going to be long days. I dread them, but I have fun at the same time. This machine absolutely scares me to death. Like, it just scares me because it's so loud, so violent. There's so much force being applied to this vise. It's just literally insane. Okay? To answer a couple questions as we go, as you guys continue to join. Popular questions are why this arm right here is going to fail. This is extremely dangerous. It's going to come loose from this head right here. And the simple answer is this bar doesn't really have any load on it. This is just a guide arm, much like a string or a cable from a wrecking ball. Okay? This weld and this bar, all it's trying to do is just guide this big heavy weight into this test bar right here. This bar does not accelerate the head. Gravity is what's doing all the work, and this is just kind of holding onto it and guiding it into place. Okay, the other thing people ask me is why is this test bar off to the side into the jaws? And what I'm hoping for too is this is worst case scenario for anybody that's hammering something in the vise, is off the side because we're trying to twist the head off. We're trying to make this vise be in a position where it's the maximum damage could happen. Okay, so that's why this test bar is on the edge. Other things we're going to talk about is the force. I'm going to turn this handle here on camera about as hard as I can do it. That's going to put us right around 12 to 15,000 pounds of force that the jaws are seeing naturally. And then we're going to be increasing that with this lever right here because we're going to be levering between these two jaws. And as you can see, it's a big lever. So we're going to probably be seeing 30,000 pounds of force with every hammer blow. Oh gosh, I feel like I'm rambling on, but hopefully everybody's here. I'll try to give you a little bit of time for everybody to gather. Is there a question that I can answer real fast to let you know that this is a live action? Conrad, is there something?
Yeah. Would you consider putting your squares to the same test?
To put it under the hammer, I've done it before, and this 100-pound hammer just literally devastates the squares. But we do have some drop tests if you'd like to see some of the squares being dropped on concrete and stuff like that. But this is the kind of stuff I do here in this space. Being a tool designer, this is how I like to test my tools. Okay, one more question that everybody says is, Jason, this is not necessary. Nobody's going to hit their vise with a 100-pound hammer. And you're absolutely right. This test is for me. This is the way I like to test, redneck style. I've been in the field long enough to see how vices are mistreated. And I want to know when you buy this vise that you can mistreat it any way you want and it's going to hold up to anything you throw at it. But this allows me to sleep at night seeing this vise take this type of punishment. So yes, nobody is going to hit a vise this hard ever. But this is me building some margin into the design and then being able to design fusible links, engineer components that will fail first so that you're not replacing entire vices when the heads drop off or when the head pops off. You can see hundreds or thousands of images online of broken vices, and I don't ever want to see one that says Fireball Tool on the side of it. So that's the goal of this experiment, okay? So welcome, enjoy the show. Once I turn this thing on, I'm going to be stepping out of the camera, and I'm going to be putting my earmuffs on, and I will not be in view at all, and I'm just going to be watching it from the side over here, waiting for a disaster to happen. Like I said, the strokes are going to be slow at first, but we'll gradually pick up the cadence as we progress to make sure everything is tight. That's another question. Everybody wants to see this thing just fly around this fast. That's not what we're trying to do here. We're trying to collect data, we're trying to film, we're trying to record, we're looking for a failure, and we want to have enough time to jump in here and stop the machine, because if this hammer swings through this bar without this bar being here, it could wrap itself around and destroy itself. That's another reason why I'm absolutely scared of this thing, okay? So I guess we're into this 10 minutes. That's enough of me yapping. Unless there's no more questions, I say we put our safety gear on and we turn this machine on and let her rip. And okay, one more thing before we go. Here's my predictions of what's going to happen. Couple things. Hopefully they don't happen. But I'm worried about these bolts. These are 3/4 bolts, grade 8 bolts that are bolting this vise down. I hope the threads don't pull out of the base plate. The next thing is I hope the test bar stays in the jaws. I don't really want to see it kitty-wampusing or moving. If it does start to move off center, I'm going to jump in, I'm going to straighten it up. Okay. The other thing is the 1/2-inch bolts that are holding the jaws to the vise. Those might snap off. If those break, we will take a pause and we'll replace them and keep going. But what I really want to see happen is what's happening in the drivetrain. I want to see this snap. I want to see the head of this vise snap off. I want to see the screw thread strip out. I want to see something disastrous happen that's not truly related to the bolting or the work holding of the vise. Okay, so that's what I'm looking for. So on camera, I'm just going to crank this thing down as hard as I can, which is going to put us around 15 to this is probably about 16 to 18,000 pounds of force. I don't really have a lot of way to get a lot of leverage on it. But I'm not going to put a cheater bar, and we're just going to watch this handle. Hopefully it stays right there. Okay, so we got a pretty good squeeze on the bar. And as you can see, that's what was our noise up to? Make sure the meter's working. 100. Okay, good check. Put our gear on and let's go. Okay, so I have a way to turn the machine off from a distance and when it's behind camera. So I'm going to turn it on and we're going to see this thing go to town. I might adjust the speed a little bit, but we're live, so bear with me. This might take us a while. Okay, here we go. Turn up the speed a little bit here. Motor's cold this morning. Wow, that rebound is crazy. Might have wrecked the hammer. Let's pull it. Might have wrecked it. Okay, we're gonna turn the audio up a little bit. So one thing I'm noticing by changing this hammer head and removing the swivel base from this equation is that you got a lot more rebound. And then this little tiny motor that I have up here at the top, it doesn't like the hammer swinging and them colliding back into itself. This is a new problem they've never run into before by having a bigger hammer. But I'm going to do a quick check up here, make sure everything's okay, and I might have to turn the speed up a little bit or figure out a way to dampen this thing. Never had this problem before. The rig broke before the Vise did so far. Okay, so just give me a second. This is just all about being alive. All the stuff that gets edited out of videos that nobody wants to watch. And what's the hand here? Trying to think if I can add a rubber band or something in there to dampen it. Let's just see if it turns back on again. That's the next step. We might have burnt the motor up trying to go the other way with it. Looks like. All right, let's try it again. We might have overheated the motor. Something's broken. I think we broke it. That didn't take long. Really? We did. We broke it. So I can see what happened. This plate, I don't know if you guys can see me. So we already broke the rig by adding this hammer and having it come back into itself on the rebound when they collide. This wasn't a problem before. It bent my motor plate. So I have two sprockets that are up there, and one of them's now like this, and it bent it. So that was an awfully short live feed. Oh, well, the Vise survived. I guess that's a good thing. This was supposed to be an all-day problem or all-day build, but I guess it's not going to happen. So this is an awfully short live stream. Well, I'm going to make some repairs, and then I guess we'll continue it after I solve this issue. So thank you guys for watching. I'll keep you updated on the problem.